All right, to build your cis and dichloroethane molecules, you're going to use Spartan. Once you have Spartan open, you can go to create a new document. For cis and dichloroethane, you're going to want to use the sp2 hybridized carbon because you've got that double bond between the two carbon atoms. And then you can put the chlorine on either cis, same side, or on opposite sides. So I'll do cis right here, just like that. You can add the hydrogen atoms here. If you don't add them and you minimize, it will add the hydrogens when you minimize. So I'll just minimize that energy. All right, and then you want to set up a calculation, and you want to be in the PM3. You don't have to change any other settings if you don't want to, and then hit submit. Again, it will ask me to save this. I say yes. I got the flags on my other screen that said the analysis is complete. And so I can go up here to this button for the electrostatic potential maps. I get this menu. I want to add the electrostatic potential map. Wait till it's done. It'll say completed, and then you can check this box. You can double click on the actual surface itself, so you get that arrow, and then turn that into a transparent version. Once you've done that, get the arrow out of the way, and then go to this info session. Okay, so if you go to info, you'll get all this information about the molecule, but you'll also see here the dipole moment, 1.1 dpi. You can display the dipole vector, and now you can see that arrow inside the molecule there. To give you a little more examples here, I'm going to do 1 and 2 propanol so you can see the difference. So propanol is all sp3 hybridized carbons. 2-propanol has the oxygen or the alcohol group on the center. Okay, so that's 2-propanol. And again, I can just minimize and it'll add hydrogen atoms wherever I need hydrogen atoms. So just like that. And then I can do a calculation. I'm going to just do this at the PM3 level and submit that. Yep. 2-propanol, great. I can show the electrostatic potential map right there. Double click. And now this is a little more interesting because you have that really strong dipole between the oxygen and the hydrogen that creates hydrogen bonding. You've got the blue, the very positive hydrogen here, and you've got the very red electron-rich density around the oxygen. You'll notice that the other hydrogen atoms don't have that dark blue color, right? They're not the hydrogen atoms that are going to participate in hydrogen bonding for intermolecular forces, right? It's going to be this one that's right here. All right, so now I can show that dipole again. This is a 1.52 dpi dipole. Display that dipole vector, and you can kind of see that it's pointed towards the oxygen. It's not just this local dipole, the whole molecule is contributing to that dipole moment right there. Okay, and we could build 1-propanol as well. So again, sp3 hybridized carbons, but this time the oxygen goes on the end, okay, of the molecule instead of in the middle. And then I do my calculations. I'm just going to use PM3. Yes. Save it as 1-propanol. Check. Okay. I can do my electrostatic potential map. All right. And double click so that I can get my transparent. I can see what's going on. I'm going to click off the molecule in order to get that arrow off. And again, I see there's the one hydrogen atom that has the partial positive charge here. And the oxygen has the partial negative, right? And everything else is just kind of blah, okay? And then I can go to this properties again, and I get 1.55 dpi, so it's a stronger dipole here than in 2-propanol, and it's in a slightly different direction, okay? And then you could just go back and forth and compare the two of them, right? This is about 1.51, and this is 1.55, so they're similar, not quite the same. If you leave this arrow here on the surface when you change this to transparent or dots or mesh or whatever you're going to do, If you leave that arrow there and then go to this properties menu, you'll get you'll get a different menu than if you unclick. So in order to take that arrow away, just double click in the blue space and then go to properties so you can see your dipole moment and display your dipole.